Hi class, please forgive my voice because I do have a sinus infection right now as I'm recording this. But what I want to talk about is transformations to parent functions. You're going to see this a lot in Algebra 2 in a lot of different contexts. Sometimes it's transformations to squared graphs like y equals x plus 2 squared minus 1. Sometimes it's transformations to cube root graphs, y equals the cube root of 2x plus 5. Sometimes it's transformations to absolute value graphs, y equals 1/2 times the absolute value of x minus 1 plus 3, and so forth. So each of these have a parent function. Here it was y equals x squared. Here it was y equals the cube root of x. And here it was y equals the absolute value of x. And then anything that is different from those parent functions, anything that's been added on, is going to transform your graph somehow by shifts and stretches and compressions, reflections. So I want to talk about a kind of elementary visual, but once I heard it, I just could apply it so many different ways, and it really helped me. Okay, so we've got a house, and the house represents the separation point, like inside the house would be inside the absolute value sign, or inside the radical symbol, or inside of parentheses. So in the house, it's really important that you sleep on a bed, and that bed is horizontal, okay? So this image is to remind you that in the house, and I'm putting quote unquote house, meaning like inside the absolute value sign, inside the radical symbol, inside the parentheses. In the house, things are horizontal. And that's because that person is on that bed and they are laying horizontally. And horizontal things are crazy in the sense of they are not what your mind would think. So, for example, this minus 1 here is in the house. You would think that a negative would shift you if you're moving horizontally, which is either left or right. You would think that it would shift you left 1, but because it's crazy, it's going to actually move you right 1. Another example is this 2 right here. Because that's been multiplied, not added or subtracted, but multiplied. That is some type of stretch or compression. And again, you would see the 2 and think, I must be horizontally stretching this by 2. But it's crazy, and so it's actually a horizontal compression by 1/2. Because it's crazy. So those are kind of the ways that I remember stuff inside of the house. Then outside of the house, you have a tree. So outside of the quote-unquote house, you have this tree, and that tree is positioned vertically up and down. And everything that's vertical is going to be normal. So some example of things that are vertical are this minus 1 that's outside of the parentheses. That is a shift because it's being added or subtracted. So it's a vertical shift. If it's going vertically, it's either up or down. Well, it would be down 1 in that case because of the negative sign. Same thing with this plus 5, with this plus 3. Those are going to be vertical shifts because they're pluses. They're going to be up 5 or up 3. Another example of a vertical is this 1/2 right here that I put out in front of my absolute value symbol. So that is being multiplied by the absolute value symbol, which is going to be some type of stretch or compression. And in that case, it will be a vertical compression by 1/2. We don't do a reciprocal here because things are normal. So it's kind of an elementary drawing, but I hope that it does resonate with you and you can see how you can use it in a lot of different examples of functions and transformations and knowing what the graphs do, getting a picture for it without even having to type it into Desmos or a graphing calculator. So I hope you got something out of that.